Okay, so let's talk a little bit. Some of you have heard the story, but I'll explain the number that's up there on the board. So, back in 2017, I started the solar project, and it's become the tradition that classes like buy a memorial panel. It's strictly optional, okay? So like these are the classes that I was teaching at the beginning, and so what I do is take the number of kids in the class, multiply it by 20. And so like on average, as everybody donates $20, then you would get like, for example, there would be like AP Chemistry 2025. Now, no pressure, but there has never been an AP Chemistry class that has not got a panel. No pressure. Okay? No pressure. I'm just saying. Okay? Just saying. AP Physics, you've already got yours. You don't have to worry about it. So there's a couple of things. Number one, thanks to Gap Sean, trying to make amends, you guys are actually already on the board with $50. So you actually have a decent start. There's some solar merch, there's hoodies, sweatshirts, that type of thing. Graduation is coming up if you want something like that. If you order anything like that, and I need the order form by Thursday. I don't need necessarily the money by Thursday, but I need the order form by Thursday. Because that's when I have to get the order in, so I can get that back. Generally, I get about $10 off of each order. So if you order something, then $10 will count towards that total. I've got order forms that should be over there somewhere around Sean. I also wrote this children's book, so fellas, if you want something kind of cute to give to your significant other, or if you just want a cool story for nephews or whatever, I can get you like a signed copy of this. This is like $15 again, about $10 of that would count towards your class total. So that's just something to consider. And for those of you that haven't heard the story, the reason I do that is because of the influence of my father, who said that you leave the world a better place than how you found it. And so that's why this has become much more emotional and much more spiritual than I thought it was going to be. I thought it was going to, hey, let's raise money, we'll get solar panels. And that was kind of going to be it. But it's become much more meaningful than that. And it kind of started, even if you look at this one that says, unless, that was donated by Katie Riffle. Katie was the one that designed that pulley system with the stapler many years ago. And if you ever read the book The Lorax, one of the lines in The Lorax says, unless people start to care an awful lot, nothing will change. It won't. And so that's why she didn't want her name on the panel. She just wanted the word unless. And so that's where that comes from. So when I've done various things, if you haven't, well, you all have seen the tattoo. But yeah, that raised like $3,000, and I've had my hair dyed and any number of stupid things that I've done over the years. So anyway, so if that's something that you would like to donate to, that would be amazing. There's Venmo, there's cash, checks to the May Solar Foundation. I do not want any of your future offspring. Don't offer me that. It's like, hey, future offspring, what's that worth? Not negotiable.
You don't want my firstborn child?
No, not really. I appreciate the offer.
What about second?
What if I name him Stanley?
Yes.
Wolfgang would consider it. No, it's Hooper and
How much for a baby?
Hoover and Hoover.
Yeah.
We have kids.
We have kids.
We each name our firstborn child Hoover and Hoover.
Gotcha.
Yes. How much is that worth?
Oh, no. So, we'll negotiate. Also, if you're helping out tonight at Mays South Elementary, that starts like at 6. And that's going to go from, theoretically, you guys need to be there maybe 5:30. They're going to have pizza, okay? So that's if you need service hours or just want to help out, especially for those of you that are coming over from Mays South, or if you went to Mays South Elementary, this is kind of a chance to give back to that. We will be in the steam room. I have no idea where that is, other than the fact that I know.
It's straight down a little bit. Go past the gym, and then it's on the right.
Okay. Did you go there?
You still here? Oh yeah, I still have siblings that go there.
Is
Oh,
that even
really?
a question?
Okay.
Like I still have an 8-year-old sister.
Okay. So they might be there tonight?
No, they'll be at the soccer game tonight.
Okay. well,
That's insane. What did you say?
Never mind.
You want to share that with the class?
All right. Anyway, so we need to talk about what you guys need for that.
Just
take it,
Princess
yes.
thing.
Yes.
Princess.
It's not princess,
Wrong.
we're chemistry
Fairies.
Fairies,
Fairies.
chemistry fairies,
Ew.
my bad.
We're not princesses.
Chemistry
Fairies.
fairies, my bad. I mean, listen, like hydrochloric acid, sodium hydroxide.
Yeah, that was
DI water too.
Okay, so what do you, so we're talking through, what do you do? You start off with,
DI water, and then we put in phenolphthalein,
I can't repeat.
and then we put in powdered sodium hydroxide, and then.
no, it wasn't powder
Yes,
sodium.
it was.
Yeah, and then
No,
we
it
put
was,
in the hydrochloric acid, and then it turns pink.
Yeah, HCl is.
So you can
Yeah.
interpret that however
You can do it either way.
like.
It turns pink either way. You just combine all the things and, wow, pink.
Okay. But Zoom, and then they add like the sodium hydroxide, that's
Ever
what
seen
makes it
that?
turn magenta.
Arnold Schwarzenegger movie.
Yes.
The
And
Predator.
then you add,
No, we
more
added
sodium hydroxide.
Oh, I thought you were about to go with,
What?
We would put water and
kindergarten
then the
pop.
powdered sodium
Yes, kindergarten
hydroxide,
pop.
mix it, and then let them
So
drop
many
in
Arnold
phenolphthalein.
Schwarzenegger movies to choose from.
And then we would put in chloric acid to turn it back to clear.
Well, we need the really hydrochloric acid, or else we use like an entire bottle to turn it back to clear.
Yeah.
Which isn't fun for the fairies.
The president.
Okay.
It's not.
That's what I said. I said the
Are you sure
Predator.
you put it in powder
That's
sodium?
the first one I
Yeah,
said.
because we had the little.
I was
scoop.
over there.
We had powder. We had powder and then everything else
Oh,
was
I
juice.
Yeah. They were all the magic juices.
So we got you.
Phenolphthalein from the
All right.
phenolphthalein tree on.
Gotcha. Okay, so let's chit chat about the assignment. We have that going?
Yeah.
Okay. All right, so let me kind of give you some,
Not even talking.
We're already starting
so
off like
the
that.
beginning
It's
of
gonna be a long
the
day.
equation starts with the idea that delta E equals Q plus W. Speaking of that equation, yes, you're having a quiz tomorrow, okay?
Oh, shoot, that's right. We have a quiz
No, are you
He
stupid?
told us that yesterday. I actually,
That
I
was
told
on
you
the
that
video.
yesterday.
like,
Yeah.
That was
I-
on
do I get
video.
any
That was
credit
very
for
funny.
Yeah.
How
Okay, it isn't like you would have
You
studied.
get 5 big.
How long is,
how long?
I would have stopped.
No, journey would have been, I waited until tomorrow to tell you.
Rude.
Oh, who was gone yesterday?
It was senior skip day.
And
What was I supposed to do?
everyone else
And-
might be.
It was y'all are nerds.
Everyone
Y'all
else.
are nerds. I had fun. I went to the ball.
Okay.
Yes. I
Did you
had
bring food here and said, hey, we're having brunch, you can take some to Mr. Burkamp? Never even crossed the radar screen.
I have not been tested.
It wasn't the same.
Okay, anyway.
Yeah,
That's self-diagnosed.
No,
It doesn't mean it doesn't mean I'm autistic.
Doesn't mean you're not.
If it's a spectrum, we're all on it.
We're all on it, that is true.
Some
Some
people.
of us
Everybody's
are than
on a
others.
spectrum.
And as you get older, this will make sense in terms of remembering things. So speaking of penguins, so the analogy is that as you get older, your brain is like an iceberg. It can
Just
only,
melts
and
away.
memories are like penguins. Yeah, so you can only hold so many penguins. Yeah, so it's like if one jumps on, the other one has to jump off. So I'm just saying, hold on to your memory because at some point you're gonna be like, you remember that penguin never made it to the iceberg.
He said, speaking of
I'm gonna get
penguins.
typed.
Well, that led to,
Wait, but what is that to autism?
it just says on the spectrum, they said, oh, you tend to forget things, and then that led to the penguin.
Oh, okay.
So it's just stay with me. Okay, all right.
Say autism
So-
bad memories. How much is
I know a guy with Parkinson's.
This is all about prepositions. Work done on a system versus work done by a system. Energy flowing into a system versus energy flowing out of a system. So what I'm gonna do is I'm just gonna give you a situation. So if you look on the assignment, on like that diagram on 5-4, okay, so they're saying, okay, here's like a visual representation. So on this one, here's your value, they've got just an arrow, and kind of the arrow represents the magnitude of it. So you've got energy flowing out. Okay, so what that means, you would physically put this thing into an ice bath. Okay, somehow or another, you're going to get thermal energy to come out of this thing. And the only way you lose thermal energy is if there's a temperature gradient. Okay, so you can think of a temperature gradient as being like a kinetic energy gradient. So you have a can of cold pop. Why does it get warm? Why does it warm up over a period of time?
Addie's hands are really warm all the time.
Okay, all right, so her hands are warm, so what?
Equilibrium.
So the more energy transferred to the left.
Photons. Photons. Yes. Photons flowing through the
Strangely warm.
can, right? Now,
The sun. Wait, how does it?
The sun.
How,
the sun.
how does it? No,
photons.
no. How does it? Again, how does? Shut up. How does it go through the can?
Okay,
The can
so
like this.
there-
Like it.
okay, so basically, if you look at it, the easiest explanation is like a kinetic energy, an explanation. So let's say that you have really cold, you have cold pop, okay?
Yeah.
And then you have warm air around it. So you have fewer collisions on the inside because that solution is colder. You have more collisions on the outside because it's warmer. And so Mother Nature basically says, okay, when you have that collision, and based upon a temperature gradient, then it says, okay, we need to try and balance that. So those collisions themselves are what's going to start the process of sending the photons through to warm that up or cool that down.
Okay.
So if you look at what's happening on this one, you have a negative Q. They don't explicitly tell you it's a negative Q, but Q is going to be a negative value because energy is flowing out. So if that's all that happened, if that is all that happened, if energy just flowed out of the system, what would happen to the temperature? It would drop because you're losing thermal energy, right? Temperature would go down. Now, not only do you have that system, so if you look at 54 part 1, or 5.4 part 1, you're going to have a negative value of Q. Work's flowing out. Now, then you're told that work, and they got an inward arrow. Now, for those of you that have studied physics, to work, you have to do two things. There has to be a force, and it has to act through a distance, okay? So notice that on that work, it's just like they're showing that you're pushing this thing in. It's just like you've got a syringe, and you're compressing it. So in this situation, it's all about the preposition. So they could have either drawn an arrow that says work is pushing it this way, or they could have said work is being done on the system. So work on the system is the same thing as compressing it. So if you look at this delta E, Mother Nature does not like to be compressed. When you do compress gases, Mother Nature flips out, and the internal energy goes up because she doesn't like it. She flips out. Like, let's say that you're claustrophobic and someone's going to wrap you up in saran wrap. You are going to flip out, okay? Your internal system is going to, bam, right? And you're going to fight against it, and you're going to, it's like, oh, and heart rate's going to go up, you're going to get sweaty, bad things are going to happen. So if work is done on a system, W is going to be a positive value. So what we have here is you have a negative Q and you have a positive W. So if all you had was the positive W, you would see the internal energy go up, okay? So you have two things happening here. You have a negative Q and you have a positive W. So if you look on the relative size of this, which one's bigger? The positive W or the negative Q?
Positive W.
Positive W. That's bigger than the negative Q, so therefore, on that question where it says, like, which process is endothermic, right? Endothermic is not the delta E value. The endothermic is the Q value. So I just want to clarify that. So on this one where it says which one is endothermic, that's the only one in which you have energy flowing into the system. Okay, so there's only one situation that fits that. Then it says for which these processes, if any, is delta E a negative value. Okay, you have to look at the sum of Q and W. Okay, so the only way that you can end up with a negative delta E is if either you have a big outflow of energy versus a small value of work, or you have both negative Q and negative W, but you have to look at this in terms of what? Okay,
People laugh.
anyway. So with that said, let me give you some hints on some of your answers. When you get to question 55, very much look for question 55 to be, a question like 55 to be on the quiz tomorrow. Okay? So I promise you, there's gonna be one like 55.
Makes me sad.
Sorry, just telling you. Now, this is all about the sign. So if you look at 55, start with this idea. So you got a 6.5 grams of sodium hydroxide dissolved in 100 grams of water, and the temperature rises from 21.6 to 37.8. Is the system, listen to me very carefully, is the system, the dissolution of the salt, gaining energy or losing energy?
Losing.
The system is losing energy. The surroundings, which is the water, is gaining energy. Because you're seeing that temperature go up. Oh, photons are entering in, the kinetic energy is going up, the thermometer is the radar gun, it's going up, oh, the particles are moving faster. Okay, so the only way you can make that water have more energy is if something gives it that energy. It's not going to gain that energy on its own. And that's a situation where, oh, okay, you got these bonds. Now, remember, is breaking bonds taking in energy or releasing energy? Is breaking bonds, do you put energy in or do you get energy out?
Put energy in.
Energy goes in to break bonds, okay? Energy is released in the formation of bonds. So right away, even before you do any math at all, you look at this and go, okay, hey, energy is going up. It's an exothermic reaction, okay? Because energy is being given off. That's what makes the water gain energy. So as soon as you know it's exothermic, what's going to be the sign of your delta H? Negative. There are certain things you have to know without fail. Sign of Q, the sign of W, what's happening with delta E, and then the signs of delta H, okay? There's going to be a much longer list. That's just the initial list of things that you need to know without hesitation.
Without hesitation?
Without hesitation,
Like for our quiz tomorrow?
maybe. So, here's what you've got. You're going to calculate Q. M delta T C sub P. Make sure that you add the mass of the sodium hydroxide in with the mass of the water for that mass value, because the mass is being added to the water. It's dissolving. It's becoming part of it. Okay? Now, is your change in temperature going to be a positive or negative number?
Positive.
Why?
Because the surroundings are gaining energy.
No, that's true,
Temperature
but just
increases.
looking at the problem.
Temperature.
Because your
Your
temperature
final
is off.
temperature is bigger than your
Initial.
initial temperature. So you're going to have a positive mass, you're going to have a positive delta T, and you're going to have a positive specific heat. By all of that, what's going to be the sign of Q for the surroundings?
Plus.
Positive. So I'm going to have a positive Q for the surroundings. Okay? So if Q is positive for the surroundings, for the system, Q is going to be a
Negative.
so you're going to switch the sign, make that negative for the system. Now your enthalpy, remember, is kilojoules per mole. But that's moles of sodium hydroxide. Don't include the water in this. It's just the sodium hydroxide, because that's what you're finding. Hey, what is it for the dissolution of sodium hydroxide? So, anyway, you do all of that. Your answer to 55 should involve a bunch of 4s.
Okay.
Okay? And also pay attention to the sign. Okay. 63 through 66, those are all Hess's law reactions. This is about showing the process. This isn't, oh, I'll just write down the equations and a miracle happens, and this is what you get for your overall delta H. So, let me give you some hints. Your overall delta H on 66 should be in the mid 100s. On 64, that should be around negative 90. Okay? The biggest thing I'm looking for is that did you show me what you did? Okay? Also with these, because you're adding them, do not round that answer. Keep those you have to keep it to those decimal places because that's the laws of significant figures. Okay. Your answer to 52B should be around 70 joules. Around. Around is a relative term.
Yeah. Yeah, it is.
Is it around an electron? Is it around the Earth? What are you talking about?
Doesn't feel really specific then.
I'm just telling you. Okay. All right, are we good? Going once, going twice.
Oh.
Sold.
I made it the green M&M.